Lecture 24, Remembering and Forgetting. So in the last two lectures, we discussed the different stores that make up human memory: sensory memory, short-term memory, and long-term memory. And we redefined short-term memory as working memory. And if you recall, working memory consists of the phonological loop and the visual spatial sketchpad. Working memory is everything that we are conscious of, right? So right now, if you're conscious of my voice, and I hope you are, you're using working memory. Sensory memory refers to everything that our senses are taking in at any one time. Long-term memory refers to information that you've stored to be retrieved at a later date. And when you remember something, let's say your first day of high school, you're bringing that information back into working memory. You're conscious of it again, and when you stop thinking about it, it moves back into long-term storage. So today we're going to talk about how we do that, how we encode information into long-term memory and how we retrieve it. This module is based on, this lecture I should say, is based on module 7.3 in your textbook. So how long we rehearse information doesn't really impact how well we remember information. And I think a lot of students struggle with this idea because you're used to using things like flashcards to learn material, where you're simply reviewing information over and over and over again. Rote rehearsal like this is actually a very poor way to learn material. And I'll give you an example of that. So this is a study by Glenberg run in the 1970s. And in this study, they had participants remember a number, 3864, and then they had them repeat a word over and over and over again. In this case, it was the word tank. And the word was repeated for 2 to 20 seconds. And then they had them recall the number that they were originally told to remember. Now, what the researchers were actually interested in was the recall of this word that they repeated over and over and over again. And what they found was that their recall wasn't impacted by the number of times they actually said that word. And we can see this in this bar plot here. So on the x-axis, we have the number of repetitions, 3, 9, 27. On the y-axis, we have the percentage of words recalled. And the number of times they repeated that word over and over and over again didn't really impact their memory for the word. Their memories were, in fact, always pretty crappy because they weren't really thinking about the word as they repeated it. They were thinking about that number. And that's the key. If you want to learn information, if you want to learn the material associated with this class, or other classes, you have to think about it deeply and relate it to yourself in some way. And this is known as an elaborative encoding. So prolonged exposure to information by thinking about its meaning. And elaborative encoding really improves memory. And there are a couple methods or techniques you can use that will help you remember information. One of those techniques is to build or construct acronyms, right? So one of the acronyms I learned in grade school, like 25 years ago, is Roy G. Biv, right? The colors of the rainbow: red, orange, yellow, green, blue, indigo, and violet. And I still remember those colors because of that acronym. So that memory is very, very sticky because I use this memory aid. Another memory aid you can use is known as the method of Loci. Loci is Latin for places. And the idea here is that you relate information that you need to learn or remember to places along a path that you take on a daily basis. So if on a daily basis, for instance, you walk through Acadia's campus on your way to the dining hall, relate places on that path to information that you need to learn. For instance, in this class, right, you have to learn the path of light through the eye. Cornea, lens, retina, lateral geniculate nucleus of the thalamus, occipital lobe. You can relate all those structures to different places on paths that you take in your daily life. This will help your memory, help your encoding of this information so that you are more likely to remember it come test time. So the key idea here is that just repeating information over and over and over again is a poor way to actually learn it. You want to think deeply about its meaning and relate the information to yourself in some way. One way to improve your recall of material that you've learned is to put yourself into the same context, state, or mood that you were in when you actually learned the material. So in this class, students often ask me if studying while listening to music is a bad thing to do. And normally I say yes, because when you're writing the test, you can't listen to music. Now this year is the one exception, right? Because you're writing the test at home. And so if you normally study with music, I would say that's fine. Just make sure that when you're writing the test, you have the same music on in the background. When you're writing the test, make sure to write the test in the same location where you actually learned the material. Right? So if you study in your bedroom, for instance, or in the library, write the test in your bedroom or in the library. This will actually help with your recall of the material. In a very famous study run by Golden and Badley in the 1970s, kind of a crazy study because it involved scuba divers. They had scuba divers memorize word lists either underwater or on land. And so the idea here is that they'd have a group of scuba divers learn word lists underwater and then recall that information underwater or recall it on land. And then the opposite situation, learn word lists on land, recall that information on land or underwater. And what we can see here is a really nice interaction. So your memory is better for, in this case, a word list, if you recall that information in the same state. So those scuba divers tested in the same context remembered 40% more words. If you learn the words on land, your recall of the words is better if you're on land. If you learn them underwater, your recall of the words is better if you're underwater. Now, once you've learned information, how quickly do you forget it? This idea was first tackled by Hermann Ebbinghaus, a German psychologist who worked in the late 1800s. And Ebbinghaus was a very interesting character. He would run studies on himself. So he would memorize lists of nonsense words, and then repeatedly over days, hours, and even weeks, he would test his memory for these words that he had memorized. And he plotted what he called a savings curve. So of the original word list that he had memorized, how much of that did he recall? 80%, 60%, 50%, and so on. What were his savings? And what he found was that his memory of word lists dropped dramatically within hours, minutes and hours of actually learning the word list. And you can see that in this figure here. So he forgets most of what he's learned almost immediately within the first hour. But after that, what he remembers sticks around for a very, very long time. So this is like weeks later. And he's still remembering 20% of the words that he had learned. So the takeaway here is that you actually forget most of what you've learned almost immediately, right? So if you're cramming for an exam, as soon as you start the exam, write down that information as fast as you can, because you're going to forget it very, very quickly. Ebbinghaus's study has been replicated in numerous sort of more modern contexts. In this particular study, they looked at English speakers who had learned Spanish in high school and Spanish speakers who had learned English in high school, and their recall, their memory of this second language that they had studied in high school but hadn't studied since. And I think in Canada we've all experienced this, right? Because we all had to take French in high school. French was the first course that I dropped in high school, quite unwisely in hindsight, because I wish my French was better. And most of what I learned in high school, French, I have forgotten. But what I do recall, things like, how to order in a restaurant or how to ask where the bathroom is, I will probably remember for the rest of my life. And that's what Ebbinghouse's forgetting curve tells us. And we can see that in this study here. So looking at our English speakers who learned Spanish in green, and our Spanish speakers who learned English in pink, and again, the idea here is that they're learning the second language in high school and then they're not studying it again. Most of what these participants learned is immediately forgotten, or forgotten within the first 2 or 3 years. But what they do remember of the second language sticks around for like 50 years. So a very impressive, what we would call longitudinal study, looking at changes in memory over a very, very big length of time. So once we've learned something, how fixed or how static is that memory? I think we have this idea that memories are very unchanging. Think about some event from high school, right? Like your first or your last day of high school. And that memory probably seems very clear and very static. But in reality, that memory has probably changed since you actually encoded the experience. We now know that memories are highly susceptible to change. So we have an experience, and that information is consolidated into long-term storage. And during that consolidation process, the memory is actually susceptible to change. When we recall the memory, it moves out of long-term storage back into working memory, and it must be reconsolidated again. At that point, the memory is also susceptible to change. And the extent to which memories can be changed has been studied extensively by Elizabeth Loftus, a famous psychologist at the University of Washington. And Loftus studied memory change in the context of eyewitness testimony. So this is in the context of people who have witnessed a crime and they're recalling the crime. So in one famous study run by Loftus and Palmer in the 1970s, they showed undergraduates clips of a traffic accident. And then they asked them a very simple question about the traffic accident, about how fast were the cars going when they smashed into each other. And the key manipulation here is that they changed the word smashed, that verb, in the question. So different groups got different verbs. One group got smashed, one group got collided, one got bumped, one got hit, one got contacted. And what did they find? They found that just changing that one word in the question dramatically changed people's memories of this event. So if you got the word smashed, you were very likely to remember the cars as moving very, very quickly before they collided. If you got the word contacted, you were more likely to remember the cars moving more slowly when they collided. So your memory for the severity of the accident was impacted later by a question you were asked about the accident, right? So we're seeing how memories here can be influenced via material you encounter actually after you've had the experience, in this case through questioning. And this work suggested that eyewitness testimony might be horribly flawed, might be very susceptible to, biased questioning by lawyers, by police officers. In one study, Loftus showed that she could actually implant false memories into people. So this is known as the misinformation effect. And so information that we encounter after an event can change our memory of that event. So in this study, Loftus had participants view video clips of a car accident, and after one group was asked how fast was the white sports car going while traveling along the country road, a second group was asked how fast was the white sports car going when it passed the barn while traveling along the country road. And the key here is that Loftus has inserted some false information into that second question. There was no barn in the scene. And what she found was that participants exposed to that false information in the question actually incorporated that information into their memory of the event. So 17% later claimed that they had seen a barn in the clip, simply because she had used the word barn in her question. 3% of those not exposed to the false information remembered barn. So this didn't happen by chance. This was really caused by her insertion of that false information into her question. And so the conclusion of the study, right, is that you can actually implant memories into people through the way that you ask them about their memory. And so Loftus's work really called into question the notion that memory is static, the notion that in criminal proceedings we can rely on eyewitness testimony. And indeed, there's a nonprofit in the US called the Innocence Project, and it uses DNA testing to free people who it thinks are wrongfully convicted of crimes. And since the early 90s, this nonprofit has worked to free about 350 people, 20 of whom were on death row. In 3/4 of these cases, the individual was convicted because of eyewitness testimony. So what this suggests is that eyewitness testimony is fundamentally flawed, and it's leading to a lot of wrongful convictions. In this case, convictions that were overturned using DNA evidence. So now we're going to do a little experiment, and I'm going to see if I can implant right now a false memory in your brain. So please take out a pen and a pad of paper. You're about to see a list of words. When the list is done presenting, write down as many of the words as you can remember. So take out a pen and a pad of paper. And again, when the list of words is done presenting, not while it's presenting, but when it's done presenting, write down as many of the words as you can remember. Okay, so hopefully you've written down as many of those words as you can remember. And so my question to you is, do you have the word fruit in your list? And you shouldn't have the word fruit in your list, but if you do, it means that I've managed to implant a false memory in your brain. And what you've experienced is known as the DRM paradigm. So all the words that you saw were related to the word fruit. So apple, pear, peach, salad, juice. Fruit is what we call the critical lure. So a word that is missing that actually might be the most obvious member of the list if you think of the list as a whole. So an example on the slide here, we have butter, jam, crust food, milk, slice, eat, flour, wine. And so the word that links all these words is the word bread. Now participants actually don't see the critical lure, but in some studies, up to 70% of participants remember the critical lure as appearing in the word list. So they're remembering the appearance of this word that is related to all the words that they saw, but they actually didn't see the critical lure in the word list. And again, if you saw the word fruit in the word list that I showed you, then you fall into this group of participants who are likely to have this false memory. Now, this doesn't always work. When I do this in class, I normally find about 15 or 20% of students remember the word that actually they didn't see, the critical lure in this case. So what does this say about memory? Well, it suggests that actually we're pretty poor when it comes to remembering the details of events. We tend to remember the gist or the overall meaning of events, right? In the DRM procedure, you tend to remember the critical lure even though you didn't see it because it relates to the overall meaning, the overall theme of the word list. Think about a film that you've seen recently. You probably don't remember, all the names of the characters, but you may remember the gist of the film, the plot. And when we recall information, we rely heavily on what we call schemas. Now, the word schema comes up again and again in psychology, so I'll define it. A schema is a representation, theory, or model used to organize knowledge or beliefs. To put that another way, our memories, our recall of events, are influenced by how we think the world works. We're more likely to remember information in a way that falls into our beliefs about the world, in a way that's consistent with our worldview. So here's an example of this. This is a study from 2008. We tend to have schemas related to gender roles, although this is changing. In this particular study, participants viewed photos of a man or a woman engaging in behaviors consistent or inconsistent with traditional gender roles. So in this photo up here, we have a man folding clothes, which is inconsistent with the gender role that we typically assign to men. In this photo here, we have a man sanding a pipe, which is more consistent with a job or a task that we would associate with men. And then in these two photos, we have the reverse. So a woman folding clothes, consistent with that gender role, and a woman sanding pipes, inconsistent with her gender role. Again, gender roles are changing, but for the purposes of demonstrating this idea and reviewing this study, what did they find? Immediately after viewing the photos, participants remembered who had performed what action. So immediately after viewing the photos, they remembered, oh yeah, the man was folding clothes, the woman was sanding pipes. After 2 days, people misremembered the schema inconsistent photos in line with their stereotypes about gender roles. So as time passed, right, they fell back on the schema that they had in their brain about, the types of jobs that women and men do. And you can see that in this bar plot here. So immediately after viewing the photos, participants were pretty good at remembering what the men and the women were doing in the photos. But days later, after a delay, their memory was more error-prone, and it was error-prone in such a way that they tended to remember men doing jobs, tasks that are typically associated with men, and women doing jobs and tasks that are typically associated with women. And so the conclusion here is that prior knowledge and beliefs really shape our recall of memories. So we've come to the end of the lecture and the lecture quiz. Question 1, what does elaborative encoding refer to? Question 1, what does elaborative encoding refer to? Elaborative encoding refers to prolonged exposure to information by thinking about its meaning. And we often contrast elaborative rehearsal, which is a good way to remember information, with rote rehearsal, which is a poor way to remember information. Question 2, true or false? Ebbinghouse's forgetting curve suggests that we forget most of what we learn within hours of learning it. Question 2, true or false? Ebbinghouse's forgetting curve suggests that we forget most of what we learn within hours of learning it. This is, of course, true. The key idea here, though, is that what we don't forget, we will remember for a very, very long period of time. So we forget most of what we learned immediately after learning it, but what we don't forget we'll hang on to for weeks, months, and even years. Question 3, true or false? Memories are unchanging representations of past experiences. Question 3, true or false? Memories are unchanging representations of past experiences. This is, of course, false. As Elizabeth Loftus has repeatedly shown, memories are highly susceptible to change, and memories are also influenced by misinformation and schemas, prior knowledge and beliefs about how the world works. The reading for next class is Module 8.1 in your textbook.